learners, welcome to the today's topic. Our today's topic is classifier accuracy. In classification, if we are going to plot a model, we are going to make a model, so that to check that we can say to check their accuracy, to check their classifier, we have to evaluate it. So that is having some of the techniques to do that. Myself, Priyanka Gupta, I am working as assistant professor in Department of Computer Science and Engineering in Data Science Department at Institute of Aeronautical Engineering, Hyderabad. I'll cover the topics today. What is the evaluation measures for identification problem of classification? So in classification, basically we are going to use some of the techniques. So first technique is confusion matrix. In confusion matrix, there are some other properties of that. There will be the ROC curve, there will be the AUC curve, there will be the accuracy, recall, precision, and F1 score. So for any particular, we can say any data set and any problem, we should have the classification. So there will have the some we can say binary type of data. There should have the multimedia multi-classes data. So if the binary classes data will be there, we can also apply the confusion matrix. We can also apply the confusion matrix for multi-class classification. What is the different benefits of that confusion matrix? We will cover. Evaluation measures for classification problem. So evaluating and estimating the accuracy of classification model, that is important. So in that, it allows one, suppose to us, to evaluate about that, how accurately the classifier is going to classify. So how accurately the classifier is working. That is how accurately that will label future data. That is on the basis of past data, how accurately that is going to label that future data. So that is that data on which that classifier has been not trained. So from the model that should not have to be trained. So on the basis of that, how accurately the classifier is working, how accurately it is going to classify the different labels. For example, suppose if you used a data from the previous sales year, so previous sales for any particular database will be there to train a classifier to predict about the future for the customer purchasing behavior. We can use that classifier, and we can also evaluate that particular classifier, how accurately that is going to classify how many customers are going to purchase that particular item or not. So that will be the classifier for that. So on the basis of that, we are having some of the measures: accuracy, precision, recall. So that the amount of that accuracy, that will depend on the how accurately it is going to be covered. It will be positive, then it is going to classify accurately. If it will be negative or less, that will not going to classify a label accurately. So you would like to estimate and how accurately the classifier can predict for the purchasing behavior of any future customer. So that will be the future customer data on which the data will be there, on which the classifier has not been trained. So for that estimation and evaluation, the classifier accuracy will be there. The classifier is having the problem of prediction, that which category, which of the new class is going to be observed belong in. So that what are the different classes can belong to that particular class level for prediction, for future prediction. So the derived model, we can say, for that we have to, suppose the classifier have to tell about that, classifier have to classify the derived model of which future model that will be having the, based on the that will have the prediction of that will be on the basis of analysis of a set of training data, where each data is a given class level. So on the basis of the there will be some training data and testing data. The training data will comes under the prediction, the predictor derived model, and on the basis of that there will be the set of training data. So on the basis of that, the model can classify a class level. A trained model, a classifier that is then used to predict about the class level for future data, unseen data, new data. So that will be the trained model. That will be the derived model is nothing but predicted model, prediction of that particular classifier. To understand about this classification matrix, how we can have the understanding of how the classifier is classifying the accurately or not, one of the most important concept is there, that is confusion matrix. So there will have some confusion also to understand that, but on the basis of that only the name is called as a confusion matrix. Some of the times we are calling it as a classification matrix. So the confusion matrix is a very useful tool for analyzing how well your classifier is recognizing tuple of different class levels, different classes. So in the right hand side in this figure, we will see this is the 2 by 2 matrix. 2 by 2 matrix is there. So in that we are having in the left hand side we are having the prediction classes. Two of the matrices are there. That has been separated as negative and positive, and that upper side that is having the actual class, that is also has been classified as a negative and positive. So there will be the true negative, false positive, and true positive. So what is the difference between the true negative, true positive, false negative, and false positive? We will see. So it can be applied. Suppose this is a 2 by 2 matrix, right? So that will be the binary classification. So on that binary type of data, we can classify that. So it can be applied to binary classifier. Some of the times there will be have multiple classes, multiple class levels. So for that also we can use that confusion matrix. So for that multi-class classification problem, we can use the confusion matrix. So there will have some 4 by 4, 8 by 8 like that matrices will be used. So the 4 element of the matrix in the right hand side, we will see in the light blue and dark blue, that is going to represent the 4 matrices that count the number of correct and incorrect predictions for the model that is predicting. So that is having the true positive, true negative, false positive, and false negative. So these are the 4 of the matrices are there to judge about what is the corrected class and what is the incorrect class. So each of the element is in this given a label that is having the 2 words. So some of the time we are calling it as a true or false, some of the time positive or negative. So it is true when the prediction will be correct. So that is there is a match. If the prediction is true, some of the classifier, if suppose if a customer is there, he is going to buy some of the diaper. Also, he is going to buy the beer. So that because he is having the small baby, he is going to buy the 2 of the items. But how to predict that? How to evaluate that? It is going to predict. So for that, a classifier confusion matrix will be there. So on the basis of that data points, the classifier will classify some of these 2 by 2 matrix, and on the basis of that, true positive, if true positive rate is comes in the matching prediction, so that will be the true for that. So prediction will be correct, then only there will be match between the predicted and ground truth tables. So then the prediction will be correct, and false when there will be the mismatch. If he's not going to buy and it is going to say it yes, so that will be the incorrect classification. There will be the mismatch between the predicted and ground truth tables. So that is having from the confusion matrix. Positive or negative refers to the predicted level. So for prediction only we can say it is true or it is false. It is positive or it is negative. Now the goal is to do that confusion matrix, to use that confusion matrix to maximize the matrix with the word true, the true positive or true negative, and minimize the other two other matrices, that is false negative and false positive. So we have to maximize the classifier, the confusion matrix, if that is classifying the correctly, that is the true positive and true negative numbers will be that will be the maximum, and if there will be the true negative, false negative and false positive numbers in less, then it is a good classification of those of the matrices. So null error rate, so there will be the term, important terminology, null error rate. So this term is used to define how many times your prediction would be wrong. So the true prediction, the correct prediction also can be wrong sometimes. So if you can predict the majority class, so if there is a multi-class, so there can have a chance to have this type of null error rates. So you can consider it as a baseline matrix to compare your classifier. So for that we have to take it as a baseline matrix. So that is nothing but that is having the null error rate. So we have to take it as a general. Evaluation measures for confusion matrix. Now the confusion matrix comes. So that is nothing but, first we will see in the right hand side, that is the confusion matrix on tumor detection. So the problem is there, the classifier is have to classify about tumor detection, if the tumor is there or not. So what is the type of tumor, that will depend on that. So that is the data points for that particular tumor detection. So there will have there is a confusion matrix 2 by 2 that is having the true negative here, true positive here, false negative and false positive. So these are the some classifiers are there. So for that we will understand what is true positive, true negative, false positive, false negative. The error rate, the accuracy of a classifier on a given test set is the percentage of test set tuples that is going to classify the correctly. The classes is going to classify as correct. The error rate, some of the time the error rate can be there, the misclassification rate can be there for the classifier. So which is, that will be called as a 1 accurate M. So where the ACC M is the accuracy of that M. So that is the error rate actually. So M stands for misclassification. Now each prediction that is going to fall into the one of these 4 matrices, the categories are there. A machine learning model is going to train to predict tumor in patients. So that is a problem. A machine learning model is going to train about what are the tumor patients are there. So the test data set consists of 100 people. So in this confusion matrix in right hand side, that total of that particular data points will be the 100. For 100 people it has been taken. 100 patients will be there. So let's look that what they are having. So for true negative, if TN is there, the data that is labeled false is predicted as false. That is going to predict as a false. If the data label is false, and that is going to predict about false, and so that is true actually. So the 60 people that will be the who don't have two tumors, but they are predicted as negatively by the model. So no and no. So that will be the true negative. That is not having the tumor, but they are corrected. They are classified as a no only. So that will be the true negative. True positive. So true positive data that is labeled true, that data that is labeled true by the classifier, and then it is going to predicted by the classifier, confusion matrix is true. True and true. So that will be the true positive. That has been matched. The condition has been matched because if 10 people are having the tumor, so that the classifier is correct, classifying the 10 people who have tumors are predicted positively by the model. So that will be the true positive for that. True positive. So there were 10 people. Okay, in that confusion matrix. That is true positive, right? Now, false positive. So that is also some of the times it is calling as a false alarm. That is having the type 1 error. That comes under the point 1 error. That is having the which the test is checking a single condition and wrongly predicting the positive. Because that is having the condition, they have to check, the model have to check the single condition. On the basis of that, that is telling it as a positive, false positive. So 22 people are predicted as positive of having a tumor. So because they are not having the tumor, but that has been classified by the classifier as they are having the tumor. Yes, they are having the tumor, they don't have tumor. So that will comes under the false positive. False positive. So they are the false positive. Right? Now we will check false negative. False negative. This is the type 2 error in which the single condition will be checked. There also the single condition has going to check. Our classifier is predicted a true instance as negative. That was the true incident. There were some 8 people were there that is having the tumor, but that is corrected as a no. That has been classified as a no. False negative. The condition is true. The false negative, as the name suggests that false. Falsely, that has been said as negative. Falsely negative. Like this, we can understand these are the abbreviations. So in that, what are the falsely abbreviated? These. So this will be the false negative. False negative. So that was the four syntaxes, four types of the classifier. That was the confusion matrix. So on the basis of that, how the classifier is going to classify correctly or not. Now, ROC curve. So, how we are going to how the classifier is going to recognize for the sensitivity and specificity. So, that measures can be used for ROC curve. Accuracy is the function of sensitivity and specificity. These are the two measures to check for the how accurate the system is, how accurate the classifier is. The ROC curve is nothing but the ROC curve is receiver operating characteristics curve that graphs that the graph that is showing the graph actually that is having the performance of a classification model at all classification thresholds. So some of the thresholds will be there that is going to plot that ROC curve. It is going to plot the true positive rate and false positive rate. So there will have some curve that is showing that ROC curve. So on the basis of that we can say the ROC curve is negative or positive. So that is plotting actually the true positive and true false positive. True positive and false positive. So on the basis of that only the curve is going to be plotted. So if you want to compute the true positive and false positive rate for the threshold, some threshold we can assign, we have to set, and the model have to set, the classifier have to set equal to 0.7. If that will have the 0.7 value, you apply the model to each example. So for each of the records, we have to apply that to get the score, and then if the score is higher, then equal to that 0.7, you predicted the positive class. So that will be the true for that. Otherwise, the classifier is going to predict the negative class. So that was the ROC curve for that. Lowering the classification threshold, if we have set the threshold as 0.7, so that is classifying more items as positive. So that should not be lower, that should be average. Then increasing both false positive and false true positive. So on the basis of lowering the classification threshold, that will happen. That is classifying the more of the positive, then it is increasing the false positive and true positive. So that will depend on the what is the threshold will be there. We set, the model has going to set. Now AUC curve. The AOC is nothing but that stands for area under the ROC curve. So it provides an aggregate measure actually of performance across all the possible classification threshold. So on the basis of that threshold, that is going to measure the performance for all the classification thresholds. The higher the area, actually that will have the some area, that is having the some area. So if on the basis of that is the area under the ROC curve is AUC, the better the classifier will be. So if that will be higher, the classifier is that is predicting right, that is predicting true. So a perfect classifier would have an AUC of 1. So if the classifier is working normally, that is having, then we will get the 1, AUC 1. The area will be 1. So that is covering all of the area actually. Usually if your model behaves well, some of the classifier is working well, we have to obtain a good classifier by selecting the value of threshold. So we have to set the threshold value very cleverly, very accurately. That is going to give the TPR, true positive rate, that is close to 1. That is having the 1 area, which while we are keeping the FPR will be for that 0. If the classifier is predicting good, that is good classifier, then FPR obviously will be 0. Accuracy measures. So for to evaluate that classifier, the accuracy matrix is there, accuracy measure is there. Accuracy is nothing but the accuracy of a classifier is given as a percentage of total correct prediction by the classifier divided by total number of instances. How many times it is dividing that? What are the different instances in that confusion matrix? On the basis of that, the accuracy formula will be there. The accuracy on the basis of sensitivity, the sensitivity into positive divided by positive plus negative plus specificity into negative divided by positive plus negative. So we have to for that formula, first we need to collect the what is sensitivity and what is the specificity for that particular classifier. Then only we are going to calculate the accuracy. On the other hand, for that confusion matrix, if we are using confusion matrix for evaluation, on the then the formula will be there: true negative plus true positive divided by true negative plus false positive, true positive plus false negative. All of the instances, what are the different 4 matrices are there. So in that particular example, the 60 negatives are there, true 60 negatives, the 10 positive negatives, the 60 again, 60 10 again, and then 22 was the false positive. That was event was false, but that has been predicted as true. So that was 22 patients. 8 that were having the false negative. The patients were tumoric, that they have tumor, but that has been classified as a negative. No, they are not having. So these are calculated by that. That will be the 70 by 100.7. So in percentage, the accuracy will be 70%. That is more good. So the classifier is telling the more of the people that has been classified as a false positive. That was 60 people. That the classifier is working well. That is only 8 people has been left for that from that classifier. So that is predicting well. That is 70% of the person, 60 people from that 68 that is having the tumor. Recall. So in that I have told already about these are the abbreviations. The recall is one of the most used evaluation matrix for the unbalanced data sets. When the data set will be unbalanced, then only that the recall will be used. Otherwise, we are using the precision. So recall is also known as a sensitivity, or we can say true positive rate. So for that, I was telling about only what is sensitivity. For the, if we are going to calculate the accuracy of that particular model, so on the basis of sensitivity, if the data set is unbalanced, that is not having the data points accurately. So on the basis of that, we have to calculate the recall. So the recall need the sensitivity or true positive rate. So that is two of the other names are there: recall, sensitivity, and true positive rate. So it is going to calculate how many of the actual positive our model predicted as positive, that is true positive. So the formula will be there. From that, the recall is equal to true positive divided by true positive plus false negative. So on the that confusion matrix or the 100% database, the 10 will be the true positive that has been true and positive, divided by 10 plus 8, that is having the 0.55, right? So on the basis of that confusion matrix, that is only depends on that confusion matrix. These are the measures are only depend on that confusion matrix. Precision measure. Recall is also known as a true positive rate, as I have said. Sensitivity, probability of detection, that is also another name for recall. Ideally, if you will see, if there is a good classifier that is classifying, that is giving the accurately, that is predicting about that particular problem is correct. So we want both precision and recall. We have to know about the precision and recall to be one, which also means false positive and false negative will be 0. So that is a condition. If the classifier will be good, this condition will occur. That is necessary to occur. Precision. Precision describes how accurately our previous data mining model is. How precise that model is. How precise that is going to evaluate that particular classification model. So precision is also called as a measure of exactness or quality. Measure of quality. Measure of exactness. So these are the two names. We can some of the times call as a positive predictive value. So the precision formula will be there. Precision is equal to true positive divided by true positive plus false positive. That is having the 10 divided by 10 plus 22. That is having the 0.31. So precision is 0.31. 31%, that is the quality is good. The 31%, the classifier is classifying the correctly. F1 score. F1 score is one another measure for that confusion matrix. So F score is help to measure the recall and precision at same time. At the one time, it is going to calculate that. So F1 score that is dividing. That is going to depend on the harmonic mean of precision and recall. That is the harmonic mean. It is taking the both false positive plus false negative into the account. So there will be the false positive classes and false negative classes. Therefore, it performing the well on the imbalanced data set. So for that imbalanced data, the model can have they can have the F1 score. They can have predict about the what is the F1 score for that particular classifier. It is difficult to compare two models with the low precision with the high recall. So if low precision will be the high, there will be the high recall. If the high recall will be the low precision. So that is a vice versa actually. If we will see in that formula also, that is comes by that only. So that is we have to make them comparable actually. We have to use them F score. So F score formula will be there. F score is equal to 2 into recall into precision. We will in formula the 2 has been multiplied by recall and precision. Then it will be divided by recall plus precision. Now, so the measures have been completed. The F1 scores will be there, recall, precision. On the basis of that, we can the model have been that is going to evaluate about how good classifier is, how accurately it is classifying the different class level. So what is the benefits of confusion matrix? So the one method we have completed, confusion matrix. So what is the benefits to use that confusion matrix? the confusion matrix, it is showing any classification model in confuse when it is going to make prediction. Now we have completed all the measures of the confusion matrix, and other than confusion matrix also, now we will see what is the confusion matrix benefits. So if we will see how many classification models will be confused to do the classification to the confusion matrix to doing the prediction. So the confusion matrix is not only going to give the insight, it is going to give the better solution into the errors. We can see the other errors directly in the 2 by 2 matrix. We can see the M into M matrix. So being made of your classifier, but also the type of errors we can also check that are going to be made. So these are the some methods, some of the benefits of that confusion matrix. The breakdown is also helps us to overcome about the limitations. So for classification, what are the limitations can be there, we can understand about that using that confusion matrix for classification accuracy. So that is alone we will be understand about the overcomes of what are the limitations can be there. We have seen in our example, the 60 tumor patients were there. 60 tumor patients were there by the while we have used the confusion matrix by the model. The 8 patients that has also the tumors, but they have not classified in that. So for that limitation, we know the 8 patients are also there, but accuracy of that model was 70%. So we are very near to the model is very near to classify the accurate class levels, but we can also overcome on that, because 8 patients were there only. Then again we can use the other type of classification models. Every column of the confusion matrix that is going to represent the instances that is having the predicted class. So on that 2 by 2 matrix, we have seen that was the actual class that is having the predicted class, and there is having the 2 by 2 matrix that is having the true negative, true positive, false negative, and false positive. Right? So that was having the negative, positive. This is positive, negative. So in that we will see that is the predicted class, that is the actual class. So confusion matrix representing the instances of all the predicted class. Each row is having the confusion matrix of representing the instances of actual class. So that was having the actual class. On the basis of these row and columns, we can understand about that particular confusion matrix. What is the actual true positive classes are there and true negative classes are there. It is also going to provide not only the error, that is going to provide the classifier's errors also. So on the basis of the classifier, how wrongly it is going to predict. So under that example, we have seen 8 patients were there. So we can also read of that is providing the insights. So that is how many times errors are showing by the classifier, because by the database set, how many by the actual data set, how many patients are there, but by the classifiers, how wrongly that has been predicted about that 8 patients. That has also the way we can read of that. So that is a benefit of that confusion matrix basically. So for the evaluation, we have used that confusion matrix today. For the on the basis of that, for the binary classification as well as for the multi-class classification, the confusion matrix can be used. There are also other methods are there, but in our syllabus, confusion matrix are there. So that was all about the today's class. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.